Section 6.1, Day 1, Graphing Systems of Equations. Essential question. Do all systems of equations have one solution? So a system of equations is two equations. So in this chapter, we will always be looking at two equations for each problem. A solution to a system of equations is where two equations intersect, and then this is written as an ordered pair. All right, first example. So you are going to try to look at what kind of lines are formed in this system, and you are going to talk about how many solutions there are. So, it says use the graph to answer the following. What kind of lines are formed? How many solutions does the system have? If there is one solution, name it. So, you will see a graph and you will see two equations written below. So the first equation is y equals negative 3x minus 5. That is my green line. So you will see y equals negative 3x minus 5 pointing to the green line. My second line I'm going to look at is 2x minus 5. So that is my blue line. So this is my system. What I want to look at now is what are these two highlighted lines doing? So number one, what kind of lines are formed? Well, when two lines like this cross, they are intersecting. So for number one, you're going to write intersecting. Second question, how many solutions does this system have? Well, two lines that intersect cross each other one time. So there is one solution. And then if there is one solution, we have to name it. So when we say name it, that means write down the ordered pair where these two lines intersect. So these two lines intersect right here where I'm making this red dot. So that ordered pair is 0, negative 3. So we didn't go left or right. So I put 0, and then I went down. Oh, excuse me, not 3. 1, 2, 3, 4, 5. I was looking at the wrong line. So 0, negative 5. So intersecting one solution, 0, negative 5 is the answer for that. These lines cross, so they're intersecting. They cross once, so it's one solution. Where they cross is the ordered pair, 0, negative 5. All right, second one. This time we are looking at the system 4x minus 2y equals 10 and y equals 2x minus 5. So my first equation, 4x minus 2y equals 10, is right here, which is pointing to the blue line. My second equation is y equals 2x minus 5, which is also pointing to the blue line. So this time they are both pointing to the same line. And the reason why that is possible is 4x minus 2y equals 10 and 2x minus 5 are the same equation, just written in two different forms. One of the equations is written in slope-intercept form. One of the equations is written in standard form, but they are the same. So when two lines are the same, we call them identical, meaning they are the same line. Lines that are identical have an infinite number of solutions, and here is why. These two lines intersect here, 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 and that will keep going forever, an infinite number of times. So for number 2, the number of solutions there are for identical lines is infinitely many. Since there isn't just one solution, there is an infinite number, we don't have to name it. All right, third one. This time we have y equals 2x plus 2, which is right here, red line. And we have y equals 2x minus 5 again, so the same one as last time, the blue line. If I look at what the yellow and both of the yellow lines are doing, they are parallel to one another. And remember, we know these two lines are parallel because they have the same slope. They both have a slope of 2. So going back to chapter 4, they have to be parallel if they both have a slope of 2. Lines that are parallel will never ever touch one another, so there are no solutions. So really in this lesson we have 3 different kinds of systems. So we have intersecting lines that create one solution. We have identical lines that have infinitely many solutions. And we have parallel lines which have no solutions. All right. Now we're at something a little different is going to happen. So we have y equals negative 2, which is my purple line. And then we have negative 3x minus y equals 5, which if you look at all of our lines, none of our lines are labeled negative 3x minus y equals 5. So what we're going to have to do to figure out which line that is solve this. Solve meaning get it into slope-intercept form. Slope-intercept forms means we want to solve for y. So we need to bring negative 3x over to the other side by adding. Remember, we did this back in chapter 4, so you have done this before. Bring down the negative y. Always write your slope first, so the 3x and then the 5. Both the 3x and the 5 are positive. Now I don't want to leave my answer as negative y equals 3x plus 5. I have to divide everything by negative 1. You cannot end with a negative variable. So then you have y equals 3 divided by negative 1 is negative 3. 5 divided by negative 1 is negative 5. So that line is negative 3x minus 5. So if I go back over to my graph, that is my green line right here. So now I've got to look at where these two lines intersect, because I can see that they are intersecting. So I'm going to write down number 1. These lines are intersecting. Remember, intersecting lines cross once, so there is one solution. And then the ordered pair where they intersect is right here where I'm making a red dot, which is at the spot negative 1, negative 2. So intersecting one solution, negative 1, negative 2. This time we've got y equals negative 3x minus 5 again, just like we had on the last one, so that is our green line. And we've got 6x plus 2y equals negative 10, which is also not one of our equations on our graph right now, so we have to solve to figure out which one it matches. So 6x plus 2y equals negative 10. We are solving for y, so bring the 6 over by subtracting it. Make sure you keep the x with the 6. Write the slope first, so the negative 6x, and then the negative 10. To get rid of the 2 by the y, we'll divide everything by 2. So y equals negative 6 divided by 2 is negative 3. Negative 10 divided by 2 is negative 5. So for our second line, we've got y equals negative 3x minus 5, which is the same as the line we already highlighted. So both of these lines are the same. meaning they are identical, and therefore they have infinitely many solutions. All right, y equals negative 3x minus 5 and 2x plus 2. So negative 3x minus 5, same one again, the green. And then 2x plus 2 is our red. So green and red are intersecting. Intersecting lines have one solution. Therefore, we have to figure out where they intersect, which this time is right here. You'll notice it's not really a nice ordered pair. It's kind of in the middle of a nice ordered pair. So we're going to look, we went about to the left about negative 1 1/2. And then we went down half of a square. So we'll do negative 1.5 and negative 0.5. Okay. Finally, we're going to summarize in a chart everything that we just did. So, we have 3 different types of graphs. We could end up with lines that intersect. So we'll describe the lines as intersecting. We could end up with just one line, meaning the 2 lines are identical, or we could end up with 2 lines that are parallel. Lines that intersect have one solution. Lines that are identical have an infinite number of solutions. And lines that are parallel have no solutions. All right, now we're going to describe the equations. Let's do identical first because that one is the easiest. Lines that are identical have the same slope and the same y-intercept because they're the exact same line. We already said lines that are parallel have the same slope, but they have to have different y-intercepts, otherwise they'd be the same line. So we'll say different y-intercepts. And then lines that intersect have different slopes because they're going opposite directions. Their y-intercepts could be the same or different. Summary. So looking back at our essential question, do all systems of equations have one solution? No. Systems of equations can have one, none, or infinitely many solutions.